Alright, here we go. We're going to do a word problem. Now, for this word problem, you probably don't want to copy all these things down, so why don't you go to the website really quick and print out a blank copy of the first question if you want. Tomorrow in class, we're going to do the second question, so we are only going to do question number 1 from the notes today. Okay? So this is what we're going to do. As you drive home from a football game, the number of kilometers you are away from home depends on the number of minutes that you've been driving. For this problem, we are going to assume that the distance varies linearly with time. Suppose that you are 11 kilometers from home when you've been driving for 10 minutes, and then 8 kilometers from home when you've been driving for 15 minutes. Define the variables and write an ordered pair. So we're going to say that obviously t is time. And we're going to say that d is distance from home. But then we're going to write our ordered pair as t comma d because time is always the independent variable. We can't change time. Okay? So part B says write an equation expressing the distance as a function of time. Okay, so what we are going to do is we need to take our first coordinate, which is 10 minutes of driving, 11 kilometers from home. And then our next one, we've been driving for 15 minutes, and we are 8 kilometers from home. And what we're going to do is we are going to first find the slope. That's going to give us 8 minus 11 over 15 minus 10, and our slope is negative 3/5. Now, negative 3/5, remember, since we are getting closer to home as we drive, our distance away from home is getting smaller. That's why we have a negative slope. So then we just need to pick a point and use point slope form. So d minus 8 is equal to negative 3/5 times t minus 15. And just distribute your negative 3/5, add your 8 to the other side, and you will have d is equal to negative 3/5 t plus 17. Okay, so that is our equation that represents the distance as a function of time. So now that we have that, what we could do is we could use that function to predict our distance from home when you've been driving for 20, 25, and 30 minutes. So all you really need is d of 20, d of 25, and d of 30. So all we have to do is substitute 20 in for x. Negative 3/5 times 20 plus 17 gives us 5 kilometers from home. And then we're going to plug in 25. Negative 3/5 times 25 plus 17. And that's going to give us 2 kilometers from home. And then finally we do d of 30. We get negative 3/5 times 30 plus 17. And we get negative 1 kilometers from home. That means you are already home. Okay? Because, you know, once you get to 0, that means you're home. This means you saw your house, you waved, you just kept on going. Maybe you're going to go get some ice cream or something. I don't know. But d of 30 means you've already been home and you've been there. Maybe you're getting ready for bed. Or maybe you're watching your Algebra 2 trig notes. D. When were you 7 kilometers from home? To do that, you work backwards. 7 is equal to negative 3/5 t plus 17, and then you just solve for t. So you subtract your 17 from both sides, so negative 10 is equal to negative 3/5 t. Multiply both sides by a negative 5/3, and you're going to get t is equal to 50/3, but we could say that it's approximately 16.667 minutes. You're not going to walk around and say, yeah, it was 50/3 minutes, you know. So you can write this as a decimal. Remember our classroom rule of 3 decimal places. Even though you probably wouldn't say 16.667, you understand. E. What does the slope represent in the real world? So I'm not asking you to say rise over run. For this particular problem, what do the time and distance intercepts represent in the real world? So again, pertaining to this problem, not when x is 0 and y is 0. So your slope is the change in distance from home over the time you're traveling. The slope represents the change in distance from home over the time you are traveling, how much closer you're getting to home. Your D-intercept and your T-intercept. So your D or your T-intercept represents, now remember, T-intercept is when D is 0, and you can just figure it out mathematically that it's 28.333, but what it represents is the time you get home, or time it takes to get home. So if you found that mathematically, you would get 28.333, which means it takes you 28 1/3 minutes to get home from the football game. Your D-intercept is when time is 0. And that means, if you look at the original problem, it's 17, and that is your starting point, or your original distance from home. Which we know is 17 kilometers. Okay, so 17 kilometers away from home takes us 28 1/3 minutes to get home. Those are our T and D intercepts. So finally, the last thing we need to do here is just sketch a graph of the model and make sure we label our axes. So we just need a little sketch for this. It doesn't have to be perfect. If you can go up by 5s if you want to. And remember, our intercept on D is 0.17. And then our T is at 28.333, 0. And we just need to sketch a little line. We don't need to go negative because obviously once we get home, we're home and we can't make time go backwards. And it says make sure we label the axes. So these are time. And this is our distance from home. And that's a little sketch, okay? It didn't say you had to do anything crazy fancy with it. It just asked you to sketch it and label your axes. And, you know, you might want to tell me that you are going up by 5s, and notice we went a little bit beyond it. That's fine. It doesn't need to be perfect. So, again, that's question number 1. And what we're going to do for this video is we're going to save question number 2 for class, and we will go through it together and let you try it and make sure that you don't have any issues. So that's that. Have a good one, and we will see you soon.